is an awesome, awesome, awesome thing. So we don't have to worry about it anymore. I'm finding my pen. Here we go. Excelente. Time to record. Okay, so here's our quiz. And the first thing we do is we talk about Billy digging holes into which he puts fence posts. Okay? One weekend he has to install 2 fences. When he starts work, there are already 5 fence posts. Ours didn't say 5. Ours said what? 3? 3. All right, there are already 3 fence posts placed, and he digs and he puts 2 more fence posts per hour. All right, does that make sense? Okay, so how many does he start with, everybody? 3. Now, most people put 3. Some people put 0. If you put 0, you have to be careful about what it read here. It says, when he begins or he starts work, there are already 3 in place. Okay? It's like maybe they were done the day before. Next, what does he add every hour? 2. So 3 plus 2 is? 5, 7, 9, 11. And we looked very, very good on that. If not, I'm sure that now it makes more sense to you. Then it says, write a function rule that determines the number of fence posts. And I want you to begin to think about functions in terms of output and input and output. The input is how many hours has gone by. What's the output? Yeah, how many posts have been put in. So the number of posts, the output, y always represents output, is 2 times the number of input, which is the number of hours that have gone by, plus what? 3. And that is my function rule. So if you remember, last week we spent 2 days talking about the different ways to represent a function. We said one way to represent a function was with a table. Then we said another way to represent a function is as a function rule. Then we talked about a picture, which this did not quiz. And we talked about a set of ordered pairs, which this did not quiz. Next, what is the rate of change? Now, some people, here's where, if you got into the 70s on your quiz, this was the big mistake that we saw. People reversed rate of change and y-intercept, or had issues with rate of change and y-intercept. The rate of change is what is changing on here. Now, there's a few different ways to do this. If we do it from a very formulaic point of view, rate of change is the same thing as slope, which is the change in y, or the change in the output over the change in the input. Now, how many, here's the y, see, post y. What's the y's going up by? What's it going up by? 2. And what's the x's going up by? 1. So the rate of change would then be 2 over 1, or 2. And the y-intercept is always where you begin. It's the amount you start with. What was that? 3. Some people reverse that. Okay? Now, I also want to go a step further and look at it in terms of y equals mx plus b. What does m stand for, everybody? Slope, which means rate of change. And what does b stand for? Y-intercept. So therefore, the rate of change is 2 and the y-intercept is 3. Now, some people put the following for the y-intercept. That's not right. It's the same. I know the concept is the same. There's a very, very good teacher over at Saxton named Mr. Angelora who teaches the honors class. And the first year that he taught this, and they put on the test, write the coordinates of the, well, they didn't say write the coordinates, I'm sorry. They wrote write the y-intercept. And many, many, many kids in his class wrote the equivalent of 0, 3, and they all missed points on their regions. This is the coordinates. But I just want to know exactly what the y-intercept is. The y-intercept is only the guy in the y place. Okay? So you had to write only 3. Now, I would say there were 4 or 5 kids in class who put 0, 3, or 3 kids who put 0, 3. Is that a big mistake? No, not at all. And that's the purpose of the quiz. The purpose of the quiz is to say, listen, let's tidy this up just a little bit. All right, the last thing is the graph. And I saw multiple mistakes on the graph. Again, little tiny things that need to be cleared up. I mentioned this the other day, and one of the great things about the quizzes is that I mention things, but sometimes they aren't as meaningful as they suddenly become. When you set up any graph, the scale has to be consistent. Whatever you want the scale to be is fine. but it must stay the same throughout. So 0, 1, 2, 3, 4, 5. I didn't even care if you didn't write the numbers down, because if you don't write the numbers, we assume every line is 1. But then over here, 2, 4, 6, 8, 10. Now what I noticed is some people put the 3 here, and then they went to 5 here. But if this distance is 2, or when you put 3 there, you made it a 3, then these 2 places must also be 3. God bless. Or these 2 places can be 2. Sam, I think you were one of the ones that did this, right? No? I know you made a little boo-boo on your graph. Well, did you like put 3 here? No, you put 2s?
No, I won't put 1s.
Okay,
No,
all right.
I
Well,
switched
a number of
them.
people, what?
I did the
Oh, yes, you switched them. That's right, that's right. Yeah, let me bring up that. Yeah, I think you were the only one who switched them. Look, this is the x-axis, right? X is what? Input or output? Input, all right? What's this one? Guys, what is this one? Output, okay? So Sam kind of reversed them. Now, this distance must stay the same through the whole problem. You can't make this a 3 and then this a 5, 7, 9. You just can't do that, all right? It has to stay consistent. The other mistake that I saw was this. All right, first off, let's plot the points. 0, 3, 5, 7, 9, 11. Now, you can draw like this. That's good. That's fine. You cannot put an arrow here. The graph does not go on forever and ever over here. Negative time. What was the x-axis again? This was the number of hours, right? So how do I keep going into the negative hours? Are we going to have like this deep discussion about the 4th dimension? That's what we're going to do. We're going to go there. All right. So everything is context. Normally when we graph a line, it's not a real life application. So of course you put an arrow on the end and it goes on forever and ever. But when you have a real life application and you have to think for a minute, well, what does the x-axis represent? It represents time. And you got to say to yourself, I can't go into negative time. So in those cases, you can never, ever, ever draw an arrow on the end here. Okay? Now, to me, this is the absolute beauty of the class, and so on and so forth. I want you to feel very safe here. I really do. I want you to feel free to make mistakes. Okay? The whole point behind the mistakes is to reveal to you little picky pieces of your awareness that you weren't set on, and now it should make more sense. Logical to everybody? Okay. I have to remember to bring in cookies tomorrow. So, all right. Now, the do it question for today. Here is an elevation versus time graph of a person's motion. Can we describe what the person might have been doing? Who wants to describe it? And I like a flair for personality here. I like fun things. You look fun. You're going to sit there and be very quiet about this?
She's not fun.
She's not fun?
No,
quiet.
She reads books all the time.
Well, that's okay. Do the books spark imagination?
No.
No? All right, well, I'm going to have some fun. You want to have some fun?
Yes.
All right. Mm-hmm. Potassium loaded. Very healthy for your heart. Now, all right. The person grabs a dead body and drags them up a stairs to a height of 10 feet. We're having fun. Then the body's so heavy that the person has to, at the height of 10 feet, it's even. So the person has to drag the body across a distance of 10 feet. Then, oh, man, is this going to be tough. The person climbs up to the top of 5 more feet in a very short amount of time and pulls the body up. Then they're exhausted, so it stays there for a little while. Then they throw the body off the cliff. Thud, 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 boom. It stops because the head hits a rock about a foot above the ground. Then, their arms being so tired, they kick the body to here where it rolls down the rest of the way. Okay? Now, was that the plot of any of the books you read? No? That sounds like a fun book. No? You know, have you ever read Dickens? You never read Dickens? Do you know who Dickens is? Okay. Did you ever watch the TV show Cheers years ago? You guys think you know what TV is. You don't have a clue what television is. The shows on TV these days, they're terrible. All they're about is sex. It's awful. Who has Netflix here? Whole class. Go home, go on Netflix, and look up the TV show Cheers. It's about a bar in Boston. And the hysterics behind this show, so many people got their acting career started in this show. Ted Danson, Woody Harrelson, Kirstie Alley, Shelley Long, Kelsey Grammer, Bebe Neuwirth. Just the list of people who got their starts in show business through this is unbelievable. So, Frasier, Kelsey Grammer, plays a brilliant psychiatrist who walks into the bar every time, and he's very stuffy, and very highfalutin, and extremely well brilliant, and so on and so forth. And then they got a mailman, and I don't know what he does, but this guy George, who's very large, and his clothes never fit. And they sit at the bar, and they pop down pretzels and drink beers every day. So Frasier walks into the bar one day, and he sits down on the corner, and he starts reading a book, A Tale of Two Cities by Dickens. And it begins with the very famous lines, "'Twas the best of times, 'twas the worst of times." And it gives you this big juxtaposition. It's considered one of the greatest works of literature in the history of mankind. So Norm and Clavin look at him and go, "What you got there, Doc?" He goes, "One of the greatest books ever written in the history of mankind. Tale of Two Cities by Dickens." They go, "Yeah, go ahead, read it." So he starts off, "'Twas the best of times." He almost sounds British. "'Twas the worst of times." And he's going on and on and on. And after about like a half a page, Norm and Clavin look up and they go, "What do you, get me the pretzels there? Yeah, can you get me a beer?" So they're bringing it over, and you can tell they have no interest in the book. They think it's terrible. So then the psychiatrist guy, Kelsey Grammer, looks at him and figures this out and goes, "And then the Apache helicopter flew up over the ridge and launched 2 Tomahawk missiles, totally annihilating the terrorists on the edge of the bridge." And they're going, "Oh, this is good. This is good." And they're sitting there 9 hours later going, "Oh, this is the best book ever written. This guy's a genius." So it's absolutely hysterical. You gotta watch Cheers. If you watch Cheers, you will see a great movie or a great show. They had shows about their middle names, and like you volunteer your middle name. Very, very few people do that. How many people don't like to talk about their middle name? So, yeah, it's a great show. You will love it.
Tell us what your middle name is.
What's that?
Tell us what your middle name is.
Carl.
Oh.
Yes.
That's not good.
So, no, it could be a lot worse. All right. What was the person's elevation at the time t equals 2? Guys, what's the height at time t equals 2? Emma? 5. Let's see. 2, 5. Good. Excellent. You see how we do that? Very importante. Here we go. Time 2. We go up until we hit the graph. And then, when we hit the graph, we go over to here, and that tells me that I have an elevation of 5. What was the person's elevation at time t equals 5? Go ahead. No, here's t equals, oh, 5. Oh, I take it back, you're right. Up there, 10, excellent, I thought that was a 5.
That's 15.
I take it back, 15. Okay, next, we're here. Between what times was the person's fastest rate of ascent? In other words, between what 2 times was the greatest rate of change? Rate of change is like slope. Emma?
Wait, between what 2 times?
Yes.
4 and 5.
Let's see. Yeah, I would say it doesn't quite reach 5, so maybe like between 4 and 4.5, right? Something like that. But can we all agree that this is the greatest slope, the biggest slope? Okay. Next up, what's the fastest rate of descent between what 2 times? Go ahead. 6 and 7. Very good. Now, I want to take just a second and talk to you about intervals and ways to say intervals. Do you remember how you had notation from the past like this, less than, greater than, and so on and so forth? That's one way that we could say an interval. But there's another way that we introduced this year for the first time. Like, let's talk about the interval from 0 to 10, okay? Now, this is a steady rate of ascent, steady rate of change. I'm going to go from 0 to, to 2. Shouldn't have said that. You see how there's brackets here? That means it includes the 0 and it includes the 10. Do you know how if I make it less than or equal to or greater than or equal to, I'm including the point? And if I don't make it or equal to, I don't include the point? Well, if I use a bracket, that means include the 0. And if I use a bracket here, it means include the 2. I know this looks like a coordinate, but it also means, in this context of this graph, the interval beginning at 0, ending at 2, but you're not allowed to equal 0 and you're not allowed to equal 2. So in other words, this would be this interval. All the numbers between 0 and 2, you're not allowed to equal them. This would be this interval. All the numbers between 0 and 2, but you are allowed to equal them. This would be all the numbers from 0 to 2. You are allowed to equal to 0 because of the staple, okay? But are you allowed to equal to 2? No, because of the parenthesis. And lastly, if I did this, what do you think that would look like?
You can equal it.
It could equal to 2, so that would be 0 and then 2. Okay? And we will do a ton more of those, but that's the introduction. The bottom line is, if you see a staple, you're allowed to equal it. If you see a parenthesis, you are not allowed to equal it. Okay? All right. So, I think that's most of what we're going to talk about today, is the intervals. Are there any intervals during which the person's elevation is constant? Yes, from here to here, which is roughly what, 4 1/4 to 6 or whatever, and this interval here from say 2 to 3 or whatever it is. Also down here from 7 to 8. Okay, those are some homework answers. All right. Not only can we answer questions like the one above for these graphs, but we also need to develop a way to express which interval we are referring to, if you will, and this is bracket notation, okay? So here is your bracket notation. Convert this one to less than symbols, less than or greater than with a variable in the middle like we just did a minute ago. Try the first one, -3 to 7. Okay, am I allowed to equal the -3, yes or no? No, so I go negative, oh, bad. -3, I'm not allowed to equal it, then my x, and then am I allowed to equal the 7?
Yeah.
Yes. Okay, 2 points. First off, if I was to graph this on a number line, it would look like this. See how we leave this circle open? Does that make sense? Because it kind of reminds you of the past. And then we fill this one in because you're allowed to equal it. Does that ring a bell with anybody?
Yeah.
Right? Did a lot of that work last year, I suppose. How many people have never seen it over what we would call bounded intervals like this before? How many people are used to seeing it more like this? Okay, so the difference between last year and this year is last year we only drew number lines where you would begin at a point and you would go in either direction forever and ever and ever. Now what we do is we add the concept of a bounded interval. And the reason we have that bounded interval is because when we do these piecewise linear graphs, over certain intervals, it's behaving one way, and over another interval, it's behaving another way. So we could either write it out the long way, as I did in this box right here, or I can write it this. This is a little shorter and a little sweeter. So you should be able to see, interpret, and understand both notations, okay? This is a way of expressing an interval, a piece of the graph. A starting point and an ending point. Does that make sense? Okay, try -2 to 3. Include the graph of what it would look like. Everybody agree? Right, we looking good? Right, comfortable? Okay. And now do the last one over there. 0 to 5. Okay, who wants to tell me the answer to how I write this in interval notation? By the way, this is called bracket notation, interval notation. This is with another way of expressing an interval. Who would, anybody? Come on, don't make me do my Ferris Bueller. Do you even know what Ferris Bueller is? Oh, you are so uneducated. You've never seen the movie Ferris Bueller's Day Off? About when the kid cut school? You've seen that. Isn't it hysterical? It is absolutely drop-dead hysterical. It's Matthew Broderick, James Cameron, some other girl, I don't remember her name. And they cut school for a day, and he's like the ultimate con artist in school. He cuts school all the time. But at one point, he has this really boring social studies professor, or teacher, and he sits in class and goes, anyone? 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 And the next day, he's taking attendance, and he gets to Ferris Bueller's name. He goes, Bueller. Bueller. Didn't you feel class just gets suddenly boring? So it's a great movie. You should watch it on a rainy day. That and Monty Python and the Holy Grail. Have you at least seen Monty Python and the Holy? Is that hysterical?
I don't know what the writers were thinking when they made that.
Why?
It's so weird.
It is very weird, but isn't it hysterical? Tell me you didn't laugh with the opening scene with the coconuts.
That's so stupid. Instead of riding horses, they just make the noise of the coconuts. I don't understand that.
Absolutely. What about when they accused the woman of being a witch?
That's so stupid too.
What about the killer rabbit?
Oh,
It's a great movie. You have to watch it. If you've never seen Monty Python and the Holy Grail, you have to see it. It's a hysterical movie. In fact, maybe I'll put it up for you in just a minute. Okay, from 0 to 5, what do we got? How do I draw? Come on. What number goes here? 0. What goes here? Less than or equal to. You know it's or equal to because it's a staple. X and then what? Or equal to 5. And then I draw my picture here. 0, 5. Fill it in. Fill it in. Fini. Make sense? Okay. Does anybody have a question from last night's homework that you need to go over? No? Okay. That being the case, I am going to first turn off my screen recording so I can start processing it. And then you have two choices at this particular point in time. You may